Let's go. Welcome to this session about the ABL language server. So my name is Gilles Querret. I'm working for Riverside software company based in France, working on continuous integration, code analysis for the OpenEdge platform since 13 years approximately. So this session will be about a language server for the ABL and why a language server. So I will first, before talking about the language server, I just would like to introduce VSCode. So this is a result, okay, to see. Resolution doesn't seem to be very good, but this is a result of a Stack Overflow developer survey that was conducted in 2021. The question was about the development environments that you regularly use in the past year, or the dev environments that you want to work with in the future. So the answer was VSCode at 71%. Second one, Visual Studios and IntelliJ, Notepad++, VIM, and then other answers. So the trend from the last years, I think that 5 years ago, the percentage was at approximately 30%, and it grew over time. So VS Code is now a leading platform for code edition, and it's something that all developers are willing to work with. So if I ask the same question in this audience, I'm not sure I would get the same percentage. However, there was a little bias here, just because OpenEdge is not currently supported in VS Code. So that might be that might explain the difference. Just in case, how many of you are working with VS Code? Yeah, not bad, not bad. So not 70%, but not bad. So just for the story, VS Code is a code editor which is developed by Microsoft and which is available for Windows, Linux, and macOS. So the project was started in 2015 and it provides a very fast environment to develop with multiple languages and provide some syntax highlight, code completion, embedded Git, support for the debugger in multiple languages. So it's a very versatile environment which is able to handle many languages. So this is a reason why it became popular. This is because it supports a lot of languages. So this is just a quick search on the marketplace for VS Code. So if you look for language support, you end up with more than 5,000 results. So there are many duplicates. Even on the first line, we can see 2 plugins for Python. However, there are lots and lots of languages which are supported out of the box or just with the installation of a simple plugin, and you have full support for the language in VS Code. So this is why it became popular, and you can even find for plugins for completely stupid languages, so Brainfuck being one of them. So if you never had a look at Brainfuck, it's a fantastic language where you have 8 symbols, so plus, greater than, square brackets, and you can do things with that. So if you have never played with such languages, you should have a look at the code golf section on Stack Overflow, and there are people doing actual impressive things using this kind of languages, and there are hundreds of languages such as Brainfuck, all using a very limited set of symbols, and all of them are supported in VS Code. So you can have some auto-completion and so on. So that was a little digression about language support in VS Code and why is it possible to have so many languages in VS Code. The reason is that Microsoft introduced the language server. And so if you don't have a language server, it means that for any language, you have to write support for a given environment. So if you have the JavaScript, you have to write a plugin for VIM, for Atom, for Visual Studio, and you have to do the same for Python, you have to do the same for Java. And so if you want to, in this case, we need 9 different implementations in order to support 3 languages on 3 different IDEs. IDEs. So the reason why we have so many languages for VS Code is that Microsoft wrote a specification saying we will provide a platform agnostic protocol so that any IDE we will be able to query the language server using a dedicated protocol, and whatever the IDEs you are using, it will be exactly the same language, the same protocol. And on the server side, in order to provide language support, you just have to abide by the specification. So you only have one implementation, and then any IDE will be able to consume the language server and say, I would like to get some information about how to format some source code. What is the available code completion at this position in the source code? And the language server, the only thing it has to do is to say, this is a list of entries that can be, that are available at this position in the source code. And so this can be consumed by VS Code, which is a primary implementation, but this can also be consumed by any other implementation because it's a protocol. So just one thing to bind them all. This is the point of the protocol. So just a few words about the protocol itself. So the language server is the implementation. The language server protocol is just the different messages that are exchanged between the client and the server. So when you open a document, the development tool will send a notification, say text document did open, and it will provide the URI of the document being opened. Then the language server will be able to say, oh, there are some issues in your source code, so you just publish some diagnostics, and it will be up to the IDE or to the client to display all the information or diagnostics that are available on a given source code. Then the user starts modifying the source code, so notification will be sent again from the client to the language server, so that the language server is kept synchronized with the modification applied by the developer. And so when the developer type control space, for example, in order to have code completion at a given point in the source code, the language server knows exactly what is the current status, and it's able to provide something meaningful in the context of the developer. And whatever the client, so you just know this is the current status of the source code, this is where this is being asked by the IDE, those are the answers. And then it's up to the IDE to display that correctly in the user interface. And so you can do that for in VS Code, there is a language server implementation per language. So there is a language server for Java, for SAS, for Python, and so on. There are lots of language servers available. And each language server can be developed, whatever the technology, everything is done through TCP communication or even HTTP. Everything is done over HTTP. So technically the client says, this is the command line where I start my language server, the port number where we will communicate, and then it's HTTP communication between two processes. So this is completely independent. In theory, it would be possible to write it in ABL, for example. However, that's done mostly in Java for ABL. So just an example of, this is something I really would like to see. This is VI running a language server extension, and so in VI it's possible to have code completion for, I don't even know what this language is, I just wanted to get some animated GIFs from a language server, and VIM using the language server. So technically, VI, it's possible to have some decent code edition while being connected over SSH to your Linux box and have something, really nice and useful working directly in a character mode on Linux. I'm a huge fan of VI, so I would like to do that. I don't know if there is an implementation for Emacs, however. But back to back to ABL. So this session will be about providing a sneak peek of what something is a prototype for ABL. So everything shown here, blah, 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 blah. This is exactly what you see on all progress slides whenever they try to announce something. I just did a copy paste of a progress slide. So what I will show you today is just a prototype. So there is nothing currently available for beta test. This is working on my machine. It sounds really promising. Many things are already working, but it's not publicly available as of today. So what I will present is the big picture of what will be done with this language server, what will be possible to do in VSCode using the language server, and then I would like to have a small discussion and questions from you about what you are looking for in a VSCode implementation for ABL. So there is no ETA. I would say maybe 2022. So that will be as vague as 2022. So, but given the expertise that Riverside has acquired over how to build applications using AND, PCT, how to analyze source code in using Cable, the parser, the information that it's possible to extract from any ABL source code, it will be available in 2022. I'm really confident that it will be possible to make that happen. So it's really an early prototype, but many things are already working. So the big picture of what I want to see here. So first, VSCode. So this is the main focus. I showed you VI running a language server, however the main focus will be VSCode. So that will be the primary target. The language server will be developed with VSCode in mind. Then I just hope it will be possible to consume and to execute the language server from VI. Maybe somebody will be able to do the VI implementation, but first, VSCode is in my mind. That's the primary target. Second thing is I want it to be platform agnostic. So I want to be able to execute that on Windows, on Linux, and also on macOS. And I will show you this machine. This is a MacBook, and I will show you how it's possible to have that running on a MacBook. So I want it to be platform agnostic. I don't want to have something only for Windows. I'm a Linux user, so I want to be able to go onto any Linux machine and start working on any application. So also Git is in my mind. So I want absolutely everything to be available in every configuration available as source code that can be versioned using Git. So I don't want any crazy file format or things stored outside of the code of the working directory. So I want it possible to clone any code repository and have everything configured out of the box. So I really want to just push the configuration directly in the Git repository, track the modifications there, and say, if I check out anything, it's automatically configured. So apart from what is really specific to your environment, so for example, if you're on Linux, the AVM will be in a specific directory, and on Windows it will be a different one. So this can't be stored in the code repository. However, the fact that I want to work with OpenEdge 12.1, that the source directory is src and src2, propath is pointing to this directory, to this other one, everything has to be plain text file and has to be stored in the code repository. It has to be extremely fast. I don't want to spend hours just indexing the content of the directory. And nothing. So I want to be able to start working, editing source code and have code completion as quickly as possible. So this means extracting symbols from the source code in a very quick way. I also want any developer machine is currently having at least 8 cores, sometimes 16, sometimes 24, sometimes 32. And I want to use as many cores as possible and really use the machine, make things extremely fast, and then everything is configured and we can use it. So that's really in my mind, make it as fast as possible. VSCode is extremely popular because it is fast, so I want to keep this thing for the ABL too. I want it to be possible to use the VSCode plugin in a web browser. This is something Thomas showed something, a dev environment running in a web browser, running in Chrome. I want to make that possible. I want to provide something that you can connect to a remote environment on a remote machine using Chrome, and you start editing ABL code. So this is in my mind. This is the main thing. Just something that had to be developed on top of the language server in order to have a decent code completion. You need to be able to build your application. So the build system, this is one of the cornerstones of an IDE. Whenever you modify your source code, you have to be able to build it as quickly as possible and get the feedback from the build system. So and PCT, this is not really suitable in this case. This is not the right technology to make to do the integration with the language server. So this is a very good tool for, I wrote it, so it's a very good tool. But this is good in a CI environment. And PCT will be maintained in the future, but this is not the right tool in a dev environment. So what has been done in this prototype is a custom system written mostly in Java and having OpenEdge workers in the background in order to, whenever a source code is modified, that will trigger an action on the OpenEdge worker, generating the R code, xref, and then the Java system will take over and say, oh, some R code has been modified, so I will extract the type information from there. Some the xref have been modified, so I will also extract some information from here. So it's a mix of Java and OpenEdge. So this is mostly based on what is available in PCT compile, the multi-threaded version of PCT compile. However, it's not exactly the same code. So technically, there are file watchers being run on the source directories and on the binary directories. The point is to detect whenever the user modifies a source code, it has to be recompiled. Whenever you modify an include file, the system, the build system, should be able to say this include file is being used in 10 files or 20 files. Those files will be recompiled. Whenever you modify a method signature in a class, the system has to be able to say this method is being used in all those other classes. I will only recompile those ones. So it has to be smart enough to immediately trigger the build of the required dependencies, and it has to be done in multiple threads. So in order to make that as quickly as possible, that will be executed in multiple threads. So if you have a very powerful machine, you will be able to run, I don't know, 4, 8, 12 workers that will recompile your source code. Also, if you switch from a Git branch to another branch, the watchers will also know that, oh, from this branch to this other one, we only change 2, 3 files or 100 files. And this is exactly what has to be recompiled, and we want to change that as quickly as possible. You want to do git checkout another branch, and you want to know immediately what has to be recompiled. So this build system, the prototype has been implemented in the demo, so it's not complete, but there is a very good beginning. The configuration file will be stored in the, as a JSON file, so we expect this configuration to be quite simple right now. So source directories with various directories, include, exclude patterns, so that will be something end-like, where you can say I would like to include those subdirectories but exclude other ones. The pro path has to be a set of procedures and PL files. Any information will be extracted from here. And then you configure your project by saying I would like to execute to use OpenEdge 12.2 or 11.7 or 9.1e with this project. One thing is that I want to be able to upgrade the VSCode implementation even when working with old version of Progress. I don't want to have a hard link between the VSCode plugin version versus an OpenEdge version. So I want to make it possible to use version 10, even if it's duplicated, with the latest version of the VSCode plugin. Also some additional things in the configuration file, dump files, database connection. I will quickly skip over those steps, but I want to have a compilation as fast as possible. So technically, there are chances that it will work with read-only connection to local databases. And I definitely want to make sure that the DF files are stored in your code repository. This is the only way you should store your database schema. You store the DF files in your code repository. This has to be versioned. So I want to absolutely enforce this convention. So regarding the basic VS Code features that are available, so it's possible to have the outline view, so with a list of variables, parameter, function, the ability to get some online help. So when you pass a cursor over any keyword, you have to be immediately the online help. This has to be valid for statements, for methods, for progress methods, or custom methods. Then code completion, which has to be based on the context, the go-to definition, even with inheritance, include files, diagnostics. This is also one of the reasons why I wanted to have a VS Code plugin, is to execute the cable rules directly in VS Code without having to set up a full project, a full PDSOE project. So I will quickly go to the demonstration. So that's live. Hopefully, it's a prototype, so there might be some risk. So this is on a MacBook. So using Docker, I will just start a new VS Code web instance and connect to it. Okay. So I'm on my MacBook, connected to the local Docker instance, and I'm able to see VS Code. So you can recognize a standard VS Code interface. We have here the OpenEdge project.json file where you have the configuration. It's a very simple project. There are only a few classes and procedures. And here we can edit some classes. So we already have syntax highlight available out of the box. Here, if we pass the, if I pass the cursor over any statement, I have access to the documentation. So this is read directly from the Progress website, so that will be kept up to date with the latest version. This is directly fetched from the website. This works for all the statements, so whether it's a defined variable or defined parameter, that will work. Here, for methods, where if I go to my class here, we can also see that we have documentation for the classes. So here we have the documentation for progress.lang.class, and we also have documentation for methods. So, and given that we use ProPath on the expression engine that has been introduced recently, the parser knows exactly which method is being used at any step. So here, x0 get property is something which returns a reflect progress.reflect.property object, and so it knows that it has to display the toString method of the reflect of the property class. However, if we go to x2 is a progress.length.object. Here, the online help just gives you the toString method for the progress.lang.object. It knows the context, and this can be in chained calls or directly a direct access to the object method. So we have, it's possible to, let me do that. I will turn on the screencast, which shows the keys. So here I can go into directly into the include files. I can navigate there. If I do some modification, I can type some message, something. I save. This is automatically recompiled. If I go here, oops, that's this one. I will just clear the output. I just add one line. Save, and this is automatically triggered. It knows that the .i, which is being referenced in my class, has been modified, so this is automatically recompiled. So it will do that for any .p which is using the .i file. Then it's also possible to have execution of the cable rules. So here, if we go there, we have the documentation for the defined variable statement, but we also know that variable x0 is read but never assigned. And this is exactly what we have here. x0 is defined here, so it automatically highlights the variable where this is being used. If we do some highlight, it knows that x0 is an instance, is a variable of progress.lang.class, so information is immediately available to the developer. It also knows about, about the context. Here it knows that this is the integer function. It's a function call, but here it knows that this is just a keyword because it's a data type declaration. So it really has a context, and this is why it will be possible to provide some good content assist, because it knows that I'm exactly at this point in the source code, so I know which attributes or methods will be available at this point in the source code. So it's a prototype. It was better for me to disable the code completion as of today because it wasn't good enough to provide some, I could have done something by hard coding a few things and say it works. I know it's not perfect and it's not good enough to show something today, but I really know that it will be possible to do that because the parser is intelligent enough to have the context. So here, if we introduce some compiler warnings, this is automatically reported by the engine. So here we know that this is a compiler warning which is raised by the compiler. If we introduce an error message, here we have a line, red thing to say this doesn't compile, and it will do that for any file which doesn't compile correctly. So I think I'm almost at the end of the session. Technically, the demonstration is what I wanted to show is done. So we will go to the questions.
What is this cross-referencing information stored between the include file and all the sources using?
So where is that stored, the cross-reference information? So this is stored internally on the language server, and that will be stored in a way that when you close Visual Studio and open it again, that will be automatically imported from something which is extremely fast to read. So this is internal format. This is not meant to be read by any other process. But yeah, this is serialized when you close VSCode. Yes, the background workers will generate the R code, including xref, and this is then read by the Java processes in parallel, and everything is parallelized. Another question? Yes?
There's a question about what progress versions are supported. Or
What?
What progress versions?
So as of today, I've used it with Progress 11 and Progress 12, but technically there is no reason other version might not be supported. So yes, it is planned to have the parser, multiple versions of the parser. Currently, the current status of the parser is we are able to understand up to 12.5, and it's not possible to say this is source code version 10. So it just accepts anything. However, what will be possible to do will be to say, I would like to have the 11.2 version of the parser and have only access to what is available in this version. So that's step 2. Yes?
It's platform agnostic just because you run it on Docker image, right?
So it's platform agnostic because everything is written in Java and OpenEdge. There is nothing else. So there is a limited amount of ABL code. So mostly what is required to execute the compilation, to connect the databases, everything else is written in Java. And so you can natively run it on Windows. You don't need a Docker to use it on Windows. Here on my MacBook, I just need Docker because of the AVM.
Yeah, that's what you meant.
Yes.
And another question would be, can we get this alpha version right now?
No, so it's not available right now. So technically, that beta version probably in 2022. I don't really have any ETA for that. And just a few additional information. So the source code, the VSCode plugin will probably stay open source. The language server will be closed source. So it will be provided mostly for free. However, that will be closed source, and then extensions will be part of a commercial offer. So technically, the execution of the cable rules, which is currently in SonarQube, something which is available under a commercial subscription, will be also available under a commercial license. I'm late. I think we have to stay there. Thank you for your time, and I will answer questions.